All right. Now problem 14. So in problem 14, we are supposed to simplify some expressions involving polar coordinates, right? So because these equations, x equals r cosine theta and y equals r sine theta, are actually polar coordinates. Polar coordinates. Right, so here we begin with some function of x and y. Z is a function of x and y. And hypothetically, if we knew the expression for f, we could substitute r cosine theta as x and r sine theta as y into f, and then we could differentiate with respect to r and theta, right? So, but basically, we need um, to do some kind of more complicated stuff. All right. Okay. So there are three parts. So let's do them one by one. Part A. Basically, we need to find dz dr and 1 over r times dz d theta. So let's do that. So dz dr is the derivative of z with respect to r is the derivative of z with respect to x times the derivative of x with respect to r plus the derivative of z with respect to y times the derivative of y with respect to r. The derivative of z with respect to x, we don't really know it, so I guess we could replace z with f, since here we have f. So fx times the derivative of x with respect to r. So this is our x, so its derivative with respect to r is just cosine theta, plus zy is fy. Well, z is, it's actually the same thing. I don't even know why they even introduced this f instead of just writing z, but yeah, that's the question. Times the derivative of y with respect to r, and this is my y, so it's just sine theta, right? Okay, so check. The first one is done. The second one, so z, the derivative of z with respect to theta is basically, again, so z x times x theta plus zy times y theta. So which is, instead of zx we write fx times x theta is minus r sine theta plus fy times the derivative of y with respect to theta is r cosine theta. Okay, and now we've got to divide it by r, right? So equals, when we multiply by 1 over r, we get, there is a minus sign in front of this, so minus fx, r over r is just 1, so sine theta plus fy. Now r, since we are multiplying by 1 over r, and it just disappears, times cosine theta, which is precisely what we were expected to get. Okay, so the second part is done. Okay, so this is part A. Now let's do part B. So part B is zx squared plus zy squared should be the same as zr squared plus 1 over r z theta squared. All right. Uh, so basically, I guess we've got to so notice that we've got to take, this is zr, and this is 1 over r z theta from the previous part, and we need to find the sum of their squares, right? So because here we have dz dr plus the dz d theta divided by r, everything squared, Okay, so what we need to do, we need to take the square of this, sorry, plus the square of this. Okay, so let me do that. um okay, so this thing is really dr is fx cosine theta plus fy sine theta squared plus the second term is uh, minus fx sine theta plus fy cosine theta squared. Okay, so let's simplify this. Um, the third term is just, we've got to take the fx squared times cosine squared theta plus twice the product, so 2fx cosine theta fy sine theta plus the second term squared fy squared sine squared theta. Right, so this is the first expression plus, now I've got to do the second one. I've got to expand basically. Okay, so minus fx sine theta squared, so it's fx squared sine squared theta. Then times the twice the product of the two, and because of the minus sign, we get minus 2fx sine theta fy cosine theta plus fy squared cosine square theta. All right, and we've got to add them together. So notice that this term minus this term is just zero. They're equal. Then here we have cosine square theta plus sine square theta, and here we have sine square theta plus cosine square theta, right? And you know, I hope you still remember from secondary school that cosine square plus sine square of anything is just one. Right, so adding them together you will get 1, so this is fx squared plus fy squared, which is precisely the left hand side, right? So this is the left hand side of our equation, and this is the right hand side of our equation. Okay, so our equation is correct.